Something happened to women's bodies 40,000 years ago that nobody talks about. Not in the history books your generation grew up with. Not in the documentaries that run on Saturday evenings. Not in the science classes that taught you about cave paintings and mammoths, and the migration of our ancestors across ancient land bridges. There is a story hiding inside the Ice Age, a specifically female story, written in bone and fat and milk and genetics, and it has been sitting in the scientific record, largely ignored for decades. Tonight, we are going to tell it, but here is the part that is going to stay with you. The part you will still be thinking about tomorrow morning when you wake up. Whatever happened to women's bodies during those 40,000 years of cold and darkness and near extinction? It is not ancient history. It is not something that ended when the ice retreated. It is still operating in your body, right now, tonight, as you lie here listening. The shape of your hips, the way your body stores and defends its fat reserves, the remarkable intelligence of your hormones under stress, the very composition of what a woman's body produces for a newborn infant, all of it was sculpted, refined, and permanently marked by one of the most brutal and sustained climatic catastrophes in the entire span of human existence. This is not a story about ice. It is a story about women, about what the female body actually is, about the intelligence it carries and the price it paid, and the extraordinary things it learned to do when the world itself turned hostile. The question this story asks is not the one you have been taught to ask. The familiar question is, how did humans survive the Ice Age? We have a general answer to that. Fire, clothing, social cooperation, migration, ingenuity. But that answer erases something. It flattens something important into a neutral, genderless narrative that obscures who specifically was bearing the heaviest biological cost. Who specifically was the critical variable in whether the species continued or ended? Who specifically changed at the cellular and genetic level in ways that have not been undone? The specific question is this: what did surviving 40,000 years of cold actually do to a woman's body? And what does her body still carry from that survival? The answer begins with a discovery made in 2008. In a cave in southwestern Germany called Hohlfels, archaeologists working in the basal layer of that cave, the oldest layer, the layer that pressed against the bedrock of the earth itself, found several small fragments of carved mammoth ivory. When assembled, those fragments formed a female figure approximately 6 centimeters long, small enough to hold completely in one closed hand, delicate enough that its carving represented hours, perhaps days, of concentrated work by someone who understood anatomy with precision and purpose. It is between 35 and 40,000 years old. The oldest clearly identifiable figurative sculpture of a human being ever found. And it is unmistakably, specifically, a woman. Not an idealized, slender woman. Not a woman whose body reflects modern notions of beauty or attractiveness. A woman whose body is full, rounded, with prominent breasts and generous reserves visible in every carved line. A woman whose body, in the hands of someone who lived through the coldest period in recent human history, was worth the effort of carving from the hardest available material for 150 years. Scientists argued about what these kinds of figurines meant. The fertility goddess interpretation, the beauty ideal theory, the shamanic object hypothesis. These explanations accumulated like sediment over the truth. And then in 2020, a team of researchers did something that sounds almost embarrassingly simple in retrospect. They measured the figurines, systematically, all of them. Dozens of these female carvings spanning from 38,000 to 14,000 years ago. They calculated the waist-to-hip ratios, the waist-to-shoulder ratios, the degree of visible body fullness in each figure, and then they compared those measurements to two things: how close each carving site was to the advancing ice front, and what the climate was doing at the time of each figurine's creation. The result was not subtle, not ambiguous, not open to multiple interpretations. The figurines closest to the glaciers were the most full-bodied. The figurines carved during the worst years of cold and starvation showed the greatest body reserves. As the ice retreated and food became more predictable, the carved figures became leaner. As temperatures fell and populations collapsed and people starved, the figurines grew heavier. These were not beauty standards. They were survival instructions, carved into the hardest available material by people who understood, with a precision that required no scientific vocabulary, that a woman's body fat was the most consequential resource their small community possessed, that the woman who could maintain her reserves through winter was the woman whose infant lived, that the line between enough stored energy and not enough was the line between a human chain. That continued and one that ended tonight, over the next hour and 40 minutes. We are going to follow that line. From a mammoth tusk figurine in an Ice Age cave to the biology operating in your body as you listen. We are going to examine what happened to women's hormones when the cold arrived, and why the female body developed a hidden intelligence that mainstream science is still mapping. We are going to travel to a frozen land bridge above the Arctic Circle, where a group of genetically isolated women spent 9,000 years in near total darkness and emerged with a change written so permanently into their DNA that hundreds of millions of their female descendants carry it today. We are going to follow the grandmothers, those extraordinary postmenopausal women whose role in infant survival during the Ice Age was so structurally decisive that it may have permanently extended the human female lifespan. And we are going to arrive, finally, at a moment of genuine understanding. Not the kind that washes over you and leaves nothing behind. The kind that settles into your sense of who you are as a woman, as a descendant of survivors, as a body that carries a 40,000-year story in its very cells. There is a lot of ground to cover. We will cover it slowly, the way this kind of story deserves, with care, with detail, with the kind of unhurried attention that allows meaning to accumulate rather than rush past. Whether you are listening closely tonight, following every word, or letting this wash over you gently as sleep draws nearer, both kinds of attention are welcome. This story rewards them equally. If you drift off somewhere around minute 30 or 40, come back whenever you are ready. Everything will still be here. These ancient women waited 40,000 years to have their story told properly. They can wait a little longer for you to return. And wherever you are tonight, whatever time it is where you live, Whatever the weather is outside your window, if you are in bed right now, you are part of a quiet, worldwide community of people who choose to spend their last waking hours exploring the deep history of our species. We would love to know where you are listening from tonight. Leave a comment if you feel moved to. There is something genuinely meaningful about knowing that this story is reaching people in their bedrooms, in the dark, across every time zone. But for now, let us begin. Let us go back 40,000 years to a world that no longer exists, and to the women who refused to let it take them down. 48,000 years ago, the first fully modern humans stepped into Europe and found something they had not been promised. They came from the east, following the corridor of the Danube River Valley westward into a continent that had never held a being quite like them. The landscape they entered was forested and relatively mild by the standards of what was coming. Brief intervals of warmth between glacial advances had allowed trees to reclaim the plains, had coaxed grasslands south of the ice sheet, had populated the valleys with mammoths, horses, reindeer, cave lions, and a dozen other species that had never learned to fear what was arriving. These earliest European settlers, the Aurignacians, as archaeologists have named them, lived in small mobile bands, 20 to 40 individuals, typically. That number is not incidental. It is the product of a specific ecological calculation. Enough people to defend against predators and share labor. Few enough that the group can move quickly when resources shift. Small enough that every person knows every other person by name. In a band of 30 people, the death of one is the death of 1/30th of your world. There is no abstraction in that grief, no institutional buffer between loss and its full weight. What we know about the women in those bands comes from multiple directions at once, and the picture that emerges is consistently more complex than the Flintstones version that sat in the cultural imagination for so long. The bones of Upper Paleolithic women tell stories. Their humeri, the bones of the upper arm, show muscle attachment markers consistent with sustained, heavy, repetitive labor. Analysis of female skeletons from this period has found physical robustness in some women that exceeds the comparative measurements of modern male athletes. These were not fragile figures who stayed close to the fire while the men did the difficult work. Their bodies record a different life entirely. She gathered roots and tubers she knew by their leaf shape and their seasonal timing, by the color of soil above them, by knowledge accumulated across generations of women who had lived and died in similar landscapes. Berries, eggs in season, nuts, plants, whose medicinal properties had been catalogued not in writing but in memory, in oral tradition, in the specific language of women teaching younger women what the earth offered and what it withheld. She fished. Archaeological evidence from Scandinavia's Irritable culture preserves fish traps, constructed with a weaving technique consistent with female craft traditions. In multiple ethnographic parallels, she wove. This is the detail that most popular accounts of the Ice Age still get wrong, because the image of fur-clad cave people is so deeply ingrained that replacing it requires effort. In the year 2000, archaeologist Olga Sofa published a study identifying more than 80 textile impressions pressed into clay fragments from the Czech Republic, dated to approximately 27,000 years ago. Not fur wrappings, woven fabric, cordage, nets, structured, manufactured textiles created using the same fundamental technique as a modern woven garment. The people who made these were not primitive in the sense that word usually implies. They were technically sophisticated, and the evidence for this sophistication lives in the same artifacts that were most likely created by women. Stay with this thought for a moment, because it matters enormously for what comes later. The Ice Age survival toolkit was not primarily made of stone. It was made of plant fiber and animal sinew and carefully constructed textiles. And the production of those textiles, the nets that caught small animals in bulk, the clothing that made the difference between surviving a -15-degree night and not surviving it, the carrying devices that allowed women to forage while keeping infants close. This was women's work. This was women's knowledge. This was, in a literal and structural sense, women's survival technology. She bore children. Here the story becomes specific and important, and something that every woman listening tonight understands in a way that is not purely intellectual. A woman in an Aurignacian band who survived childhood and reached her reproductive years, likely delivered between 6 and 10 children across her lifetime. Not all survived. Paleolithic infant mortality was severe, but the pattern of birth was continuous because in a small band, every new person mattered. Every child who survived to adulthood was an investment in the future of the group, and birth itself, even 40,000 years ago, was already the most dangerous biological event a female human would ever face. The obstetric challenge that makes human childbirth unique among mammals was already fully present. Bipedalism had narrowed the birth canal. The human infant's skull, enlarged by a brain that was evolving rapidly toward the complexity it carries today, had to navigate a passage that nature had not had enough time to redesign adequately. Birth required help. It required another human being present, a set of experienced hands, a body of knowledge about position and timing and complication. It required midwifery. The practice of midwifery traces to the Paleolithic, to approximately 40,000 years ago, not as a formal profession with credentials, as a necessity, as one woman helping another through the most vulnerable moment in a female body's experience, using knowledge that had been accumulated across 100,000 years of trial and loss. This is the world, competent, intimate, brutal in specific ways, beautiful in others, that the cold arrived into. A world where small groups of women and men had found a workable equilibrium with their environment, where the daily caloric mathematics were difficult but manageable, where an average woman's life expectancy was approximately 35 to 40 years. But those years were physically full, socially dense, and organized around a sophisticated understanding of the natural world. And then, beginning around 38,000 years ago, the equilibrium began to break. Not all at once, not with any announcement, just a slow, accumulating change in the air temperature, the plant distribution, the reliability of the seasons. Just the beginning of what researchers now call the last glacial period's upper Paleolithic phase, 40,000 years of cold that, would reshape not just the geography of the Earth, but the biology of the women who lived within it. What researchers found when they looked at the evidence from this transitional period reframed their understanding of what survival actually required, and who, specifically, the ice was most demanding of. 8 degrees Celsius. Hold that number for a moment before we move on. In daily life, 8 degrees is unremarkable. It is the difference between wearing a light jacket and not wearing one. It is the spread between a cool morning and a warm afternoon. In isolation, in the context of ordinary human experience, it barely registers. But applied across an entire continent, embedded in the average annual temperature of a landmass, woven into the baseline cold of every winter, every spring, every autumn, 8 degrees Celsius is catastrophic. It is the climatic distance between the temperate forests that sheltered early European humans and the frozen steppe that replaced them. It is the margin between roots you can dig and ground frozen to hard to penetrate. Between a forest that provides shelter and fuel and a windswept plain, where nothing tall enough to block the wind will grow. Beginning around 28,000 years ago, temperatures across Europe and Asia began to fall toward that 8-degree shift. The process was not uniform, not linear, not identical across all regions. Some areas experienced it faster. Some pockets of the landscape remained warmer longer, becoming refugia, places of relative shelter where populations contracted and clustered and survived. But the broad trajectory was unmistakable, and its human consequences were recorded in the most durable material the human body produces: teeth. Dental enamel is laid down in childhood, during the years when a body is growing and its nutritional needs are most acute. When a growing child experiences a period of severe nutritional deprivation, a winter of genuine starvation, a season of disease-driven caloric depletion, the enamel forming at that moment is disrupted. The result is a thin horizontal line etched permanently into the tooth surface, visible to researchers examining the skeletal record thousands of years later. It is called enamel hyperplasia, and it is the body's indelible diary of hardship among the earliest Upper Paleolithic populations, the ones living in the relatively milder conditions of the period before the cold's full descent. Enamel hyperplasia appeared in approximately 16% of teeth examined, a significant number, not a population living in comfort, but the baseline level of nutritional stress in a challenging but survivable environment. By 22,000 years ago, at the peak of the last glacial maximum, that number had risen to 29%. Nearly 1 in 3 individuals carried permanent evidence of at least one significant episode of childhood starvation, written in the hardest tissue in their bodies. Unambiguous. And then there is stature. Average human height across European populations fell by 3 to 4 inches, 7 to 10 centimeters, between the early Upper Paleolithic and the last glacial maximum's peak. This is an enormous shift. Height is a reliable proxy for the nutritional environment of childhood and adolescence. Shorter generations are generations that grew up hungry. The shrinking of the human body during the Ice Age's worst decades is not a mystery. It is a direct, skeletal record of what decades of caloric scarcity do to developing bodies across generations. the European human population itself declined from approximately 330,000 individuals around 30,000 years ago to fewer than 130,000 at the glacial maximum, around 23,000 years ago. This calculation comes from a 2015 study in the Proceedings of the National Academy of Sciences. Using paleoclimate modeling combined with analysis of archaeological site distribution, more than half the human population of Europe gone, not to disease, not to warfare, to cold, to starvation, to the simple equation of a climate that produced less food than the people living in it. Needed to survive. You are descended from the ones who stayed. Think about that for a moment. Right now, lying wherever you are, in whatever warmth you have around you, you are the product of the lineage that survived. Every woman who carried your genetic material through those 23,000 years ago survived something that killed more than half the people round her. Not through luck alone, through specific biological capacities that her body had and others did not. Through specific social relationships that kept her alive when individual survival was insufficient. Through knowledge that was preserved and transmitted in the chains of women who taught other women. But here is what this chapter is specifically about, and why the female story of the Ice Age is different from the general human story. The cold did not affect men's bodies and women's bodies the same way. The caloric demands, the physiological responses, the evolutionary pressures, they diverged at the point of greatest biological difference between the sexes, which is reproduction, and what the Ice Age demanded of women's reproductive biology specifically is the part that most history has simply not examined. Here is where the question that will take us through the next hour begins to crystallize. If starvation was shrinking human bodies, if the nutritional stress was so severe that it is written in teeth and bones across multiple archaeological sites, why were the figurines carved during those exact years consistently depicting women who were not thin? Why were the oldest artists in the world working by firelight in rock shelters while the temperature outside reached -15 degrees, spending their most careful creative energy on images of women whose bodies were full, rounded, and well-nourished? The evidence from this period reveals something that reframes everything that came before. Something about what the female body was doing during those decades that mainstream science took a long time to understand, and that the people living through it somehow already knew. A woman's body does not respond to starvation the way a man's body does. This is not a soft observation about biological difference. It is a structural fact with deep evolutionary roots, and those roots run directly into the Ice Age, with a precision that makes the connection impossible to overlook once you see it. Women carry more subcutaneous fat than men. The fat beneath the skin, distributed across the hips, the thighs, the lower abdomen, that is specifically different in its composition, its metabolic behavior, and its evolutionary function from the visceral fat that surrounds internal organs in men. This distribution is hormonal. It is governed by estrogen. It has been conserved through millions of years of primate evolution, and in the context of 40,000 years of advancing cold. It was not incidental to women's survival. It was central to it. Subcutaneous fat insulates. Physically, literally, It reduces heat loss from the body surface in cold environments in ways that visceral fat cannot. Because visceral fat is deep inside the abdominal cavity and cannot serve as a thermal barrier, the way a layer of fat beneath the skin can. Women's higher subcutaneous fat reserves function like the insulation inside a wall. The same principle applied to a living body, maintaining core temperature at a lower caloric cost than shivering, which burns energy at enormous rates. In negative 15-degree air, the energy cost of maintaining 37 degrees of core temperature for a human body is immense. A body that can reduce that cost through insulation rather than through constant muscular thermogenesis is a body that is more efficient. A body that can last longer on the same food supply. But the fat story goes deeper than insulation. Much deeper. A woman requires approximately 17% body fat to maintain regular menstruation. Below that threshold, the hormonal signaling that governs the reproductive cycle begins to deteriorate. Her body knows, in the hormonal language that predates conscious thought by millions of years, that conditions are not sufficient for reproduction. At approximately 22% body fat, the conditions for a healthy pregnancy become possible under normal nutritional circumstances, and to sustain a pregnancy from conception through to weaning. An infant to provide the caloric content of breast milk across the months of nursing that a Paleolithic infant required, the body needs access to approximately 16 kilograms of stored fat reserves, not pounds, kilograms, 35 pounds of stored energy at minimum, dedicated solely to keeping another life alive through the coldest and most calorie-scarce months of the year, during the worst years of the last glacial maximum. Those reserves were not theoretical. They were the difference between an infant that survived its first 2 winters and one that did not. Your own body carries this legacy in the pattern of its fat distribution right now. The way women's bodies preferentially store fat in the hips and thighs, rather than around the abdomen, a pattern that puzzles doctors and frustrates women across the modern world, is not a design flaw. It is the signature of exactly this selection pressure. The fat stored there is subcutaneous fat. It is insulating fat. It is nursing reserve fat. It is Ice Age survival fat, optimized over 40,000 years of precisely the kind of pressure of the last glacial maximum. Apply. Now stay with me here, because what happens next in this story is where the female body reveals something that most people, including most scientists, until recently, did not understand. When caloric intake falls below the threshold necessary to sustain both a woman's basic metabolic requirements and a pregnancy, the body makes a decision. Not a conscious one, not a deliberate choice, a hormonal one made below the level of awareness. In the ancient biochemical language of the hypothalamus, the reproductive system reduces its activity. Ovulation becomes irregular. The hormonal cascade that supports a developing pregnancy weakens. In cases of severe and prolonged nutritional deprivation, menstruation stops entirely, a condition called hypothalamic amenorrhea, where the brain essentially redirects the energy that would have supported reproduction toward keeping the existing body alive. This is not a failure of the female body. This is one of the most sophisticated survival calculations in all of mammalian biology. The body is performing a calculation that no conscious mind could replicate in its speed or precision. We do not currently have the reserves to grow a healthy brain, a robust immune system, and a body capable of surviving outside the womb. We will not commit to that process now. We will maintain the capacity. We will store what we can. And when conditions improve, we will be ready. Think about what this means for a woman living through the Ice Age. In the worst winters, the winters of -15 degrees, the seasons when the prey animals had migrated to far south to follow, when the plant foods were buried under meters of snow, when the caloric mathematics simply did not add up, her body was not failing. Her body was making exactly the right decision. Pausing reproduction, preserving the capacity, protecting the possibility of future children by not attempting an impossible. Pregnancy during an impossible winter. The women whose bodies were most responsive to this mechanism, whose reproductive systems were most finely calibrated to the available food supply, who could pause and restart the hormonal cycle with the greatest accuracy, were the women most likely to survive the worst years and reproduce successfully in the better ones. This calibration refined over 40,000 years of exactly this kind of pressure, is still operating in the bodies of women alive today. It is why the stress response, chronic nutritional stress, or caloric restriction below certain thresholds, still triggers hormonal disruption in female reproductive systems. The body has not forgotten what the Ice Age taught it. There is one more layer to this, and it is the one that connects the female body's fat intelligence directly to those carved figurines. Researchers studying modern hunter-gatherer populations, including the Hadza women of Tanzania, one of the few remaining societies that live in a way broadly comparable to Upper Paleolithic conditions, have documented something important. Hadza women foraging in lean seasons show measurable hormonal suppression of their reproductive cycles. The same women foraging in seasons of abundance show restored fertility. The body reads the environment through the lens of available calories, and it responds with remarkable precision 40,000 years ago. In the cold and the dark, the women who were most capable of maintaining adequate fat reserves were the women whose bodies could sustain the hormonal balance, and the bodies of those women were clearly, demonstrably, considered beautiful, not because thinness was unattractive, but because fullness, in that context, meant alive. It meant capable. It meant the body could do what needed to be done. The question that lingers after all of this is one that science is still debating. And it takes us directly to those figurines and to what they were actually for. Imagine you are in a rock shelter in what will someday be Germany. The year is somewhere around 30,000 years ago. Outside, the temperature has been below freezing for 4 months. The last hunting expedition returned with less than expected. The children are quiet in the way that children get when they have been hungry for too long. You are holding a small piece of mammoth ivory, and you are carving. What do you carve? You carve a woman. Specifically, you carve a woman whose body is full, whose breasts are heavy with the capacity to nurse, whose hips and abdomen carry the visible reserve that means she will not run out. You carve her without a face, because the face is individual, and this object is not meant to represent one woman. It is meant to represent an ideal, a state of being that your community desperately needs. A body condition that is the difference between your group's children surviving this winter and not surviving it. You are not carving a goddess. You are not carving a fantasy. You are carving a survival manual in 3 dimensions, small enough to hold in a closed hand, portable enough to carry with you as your band moves south chasing the retreating prey herds, durable enough to outlast everyone who made it by 40,000 years. This is what the 2020 study published in the journal Obesity proposed. After systematically measuring every known upper Paleolithic female figurine against the climate data and geographic data of their creation sites, the researchers, led by a team at the University of New Mexico, compared the degree of body fullness shown in each figurine to 2 variables: how close the site was to the advancing glacier at the time of carving, and what the climate was doing at that moment in history. The relationship was statistically clear and emotionally resting. The figurines from sites closest to the glacier front, during the years of maximum glacial advance, showed the greatest body fullness. As you move the sample south, away from the ice, the figurines become progressively leaner. As the climate warmed after the last glacial maximum and food became more reliably available, the figurines carved in that period show noticeably less body fullness than those from the worst years. The pattern is not subtle. It tracks the climate with a precision that is, in retrospect, obvious once you know what you are looking at. Here is the number that makes this visceral rather than abstract. A woman needs approximately 22% body fat to sustain a healthy pregnancy. During the peak of the last glacial maximum, nutritional stress was severe enough that enamel hyperplasia or starvation markers in teeth appeared in nearly 1 in 3 individuals across the population. Average stature had fallen by up to 4 inches from earlier generations. The population itself had declined by more than half. In that environment, a woman maintaining 22% body fat through winter was not ordinary. She was exceptional. She was the one whose children lived. She was the ideal that other women, especially young women entering their reproductive years, needed to aim for. The Venus of Willendorf, the Venus of Lesbube, the Venus of Dolnivstonis, the Venus of Hohlfels, dozens more scattered across cave sites from the Pyramids to Siberia, spanning 24,000 years of continuous artistic production during the coldest period. In recent human prehistory, all of them female, all of them full-bodied, all of them faceless, because the message is about the body state, not the individual. All of them small enough to be handled, carried, worn. Some researchers believe they were used in teaching, passed from older women to younger women. Physical representations of what the female body needed to achieve in order to reproduce successfully. Some believe they carried spiritual or ritual meaning, invoking the abundance that was desperately needed. Some argue for both simultaneously, that in a world where survival and the sacred were not separate categories, a practical survival tool and a ritual object were one and the same thing. The debate is genuine. Archaeologists of standing are on both sides. But here is what both interpretations agree on. These objects were created by people under extreme nutritional stress, who chose to represent female body fullness with such care and consistency. Over 24,000 years that the pattern cannot be coincidental. Whatever the specific mechanism of meaning, teaching, ritual, aspiration, invocation, the figurines were encoding. Something that those communities understood about the female body and survival that we have spent 150 years misreading as fertility fetishism or ancient pornography. Archaeologists spent 50 years categorizing these figurines primarily as sexual objects or religious symbols. When the 2020 study reanalyzed the full corpus with a climate lens, the evidence pointed to something far more practical and far more specifically female. What else have we been misreading about ancient women's knowledge and ancient women's purposes? Now here is where the scientific debate becomes worth your opinion. The 2020 study's methodology was rigorous, but some researchers have pushed back. They argue that the carvers of these figurines were selecting for qualities that were symbolically associated with fertility and abundance, not necessarily coaching specific body fat percentages. They point to the fact that not all figurines from glacial zones show equal obesity, and that stylistic variation across cultural groups complicates any simple climate correlation argument. Others note that the figurines production cluster does not perfectly match the worst years of nutritional stress. Some of the most robust figurines predate the last glacial maximum's peak. Both positions have evidence. The climate correlation is strong enough to be meaningful. The symbolic interpretation has merit. That doesn't disappear simply because a practical interpretation is available. What do you think is closer to the truth? If you were holding one of these figurines in a rock shelter 40,000 years ago, what would it mean to you? But the figurines are only one thread in this story. The next thread leads north, farther north than almost any human being had ever gone before, to a frozen landscape above the Arctic Circle, where a small group of women were about to do something that changed the biology of their female descendants permanently, and that is still operating in the bodies of hundreds of millions of women alive right now. By 32,000 years ago, a small population of modern humans had done something that seems almost incomprehensible. From where we sit tonight, they had established a year-round settlement at the mouth of the Yana River in Siberia, at a latitude of 70 degrees north. 70 degrees north. To give that latitude meaning, at 70 degrees north, the sun does not rise above the horizon for approximately 2 months in winter. The days in late autumn and early spring are so short that the sky is dark for most of what we would call daylight hours. The UVB radiation from sunlight, the specific narrow bandwidth of ultraviolet light that human skin requires to synthesize vitamin D, reaches the Earth's surface at those latitudes at levels close to zero for most of the year. The people at Yana were extraordinary. They were hunting woolly mammoths and woolly rhinoceroses at the edge of the world. They were surviving in conditions that modern humans equipped with the full technology of industrial civilization would find challenging. And they were doing it because the warming of the brief interstadials, those periods of relative warmth between glacial maxima, had made it briefly possible. And because they were by every measure we can apply, astonishingly adaptable. Then the last glacial maximum arrived. The temperature dropped. The land to the south and east became progressively less habitable. The ice sheets to the south, the massive Laurentide ice sheet covering what is now Canada, and the Cordilleran ice sheet covering what would become the mountainous west, coalesced. They merged into a single, impenetrable barrier of ice, the land bridge between Siberia and North America, the Bering Land Bridge, a broad plain exposed by the ocean's drop in sea level, was accessible, but the route beyond it, into the Americas, was blocked by a wall of glacial ice that nothing living could cross. The people in Beringer, the ancestral population of every indigenous person in the Western Hemisphere, as genetic analysis has established with as much certainty as ancient genetics can provide, were trapped, not suddenly, not obviously, in any single moment, but over generations, as the climate shifted and the ice consolidated. The corridors that might have allowed them to move became impassable. They were in Beringer, above the Arctic Circle, in the dark, and the genetic analysis of Native American populations worldwide suggests they stayed there, genetically isolated from all other human populations on Earth, for approximately 9,000 years. 9,000 years is not an abstraction. It is the entire span of recorded human civilization. It is longer than the gap between the construction of the Egyptian pyramids and the moment you are listening to this. It is a compression of time so vast that 99% of the people who ever lived are contained within it. And this small population of women and men lived through it, in the dark and the cold, in near total biological isolation, and emerged, as the genetic record shows, having undergone specific evolutionary adaptations that are detectable in their descendants. Bodies today, the most significant of those adaptations is female, not male-specific. Not neutral, female. A 2018 study published in the Proceedings of the National Academy of Sciences, led by researchers including paleoanthropologist Leslie Lascaux at the University of California, Berkeley, investigated a specific genetic variant called EDA V370A. The EDA gene, the ectodisplacin A receptor, has several known effects on the development of ectodermal structures, hair, teeth, sweat glands, and mammary tissue. The V370A variant of this gene is found at near universal frequency in the indigenous populations of East Asia and the Americas. In European or African populations, it is effectively absent. Geneticists had noticed this variant for years. Previous explanations focused on its effects on sweat gland density, perhaps an adaptation to cold, dry air, or to changes in thermoregulatory sweating. But the 2018 study proposed something different, more specific, more female. The EDA V370A variant increases the density and branching complexity of mammary gland ductal tissue. Not subtly, measurably. The ducts in breast tissue that carry milk from the glandular cells to the nipple. The structural network that determines how effectively a mother can transfer fat. Fat-soluble vitamins, immune factors, and critical fatty acids to a nursing infant are more elaborate, more branched, and more functional in women carrying the EDA V370A variant. At latitude 70 degrees north, For 9,000 years, in near total darkness, the most critical survival challenge for nursing mothers was not cold alone. It was vitamin D. The body synthesizes vitamin D from UVB sunlight. With almost no UVB available for most of the year, the women in the Beringen refugium were severely and chronically vitamin D deficient. And vitamin D deficiency in pregnant and nursing women has cascading consequences for the developing infant's bone mineralization, for immune function, for neurological development, for everything that determines whether a baby born into extreme conditions will survive the first 2 years of life. The EDAR gene's effect on mammary ductal branching increased the efficiency of vitamin D transfer through breast milk. More branching means more surface area for the specialized adipocytes, the fat cells that produce breast milk, to concentrate and transfer fat-soluble vitamins, including vitamin D. More branching means more capacity to load milk with the nutrients that deficient maternal bodies could provide only in limited quantities. The selection pressure was specific to women, specifically to nursing mothers, specifically to the transfer of nutrients from a woman's body to an infant through breast milk. And it was intense enough, the stakes high enough, the advantage significant enough in terms of infant survival, that over approximately 9,000 years of genetic isolation, it drove the EDA V370A variant from whatever lower frequency it had, started at 2 near universal presence in the ancestral population. Every woman in the indigenous Americas and a significant proportion of East Asian women alive today carry this variant. Hundreds of millions of women, all of them carrying, in the genetic structure of their mammary tissue, the record of 9,000 years of darkness above the Arctic Circle, and of the women who nursed their babies through it. Parallel to the EDA selection, the same population showed evidence of selection on a second gene cluster, the FADS genes, which govern the production of long-chain polyunsaturated fatty acids including DHA and arachidonic acid in breast milk. These fatty acids are essential to infant brain and visual development. The Beringen women's diet, centered on marine mammals, oily fish, and Arctic megafauna, was rich in the omega-3 precursors for these critical nutrients, and their FADS gene variants shifted to optimize the conversion of dietary omega to 3 fatty acids into the specific forms that breast milk carries most effectively. 2 genes, both selected in women, both operating through breast milk, both driven to near fixation in the ancestral population by 9,000 years of a specific environmental challenge, and both still functioning in the descendants of those women today, affecting the composition of breast milk in women who carry the variants, operating completely below the level of awareness, as quiet and persistent as the Arctic itself. There is something that is almost never said plainly in the popular histories of early human life, and it is this: for most of human prehistory, giving birth was the single most dangerous event in a woman's existence. Not illness, not predation, not the violence of a hostile world, pressing in from every direction. Birth, the act of continuing the species, the most fundamental biological function, that falls uniquely to the female body, was the event most likely to end a woman's life before anything else did. And in the Ice Age, Under conditions of nutritional stress, physical exhaustion, and bone-deep cold. It was more dangerous than at almost any other point in human history before or since. The reason for this is built into the architecture of the female body itself, and it goes back much further than the Ice Age. It goes back several million years, to a moment in primate evolution when two competing pressures began to work against each other in the female pelvis in ways that have never been fully resolved. The first pressure was bipedalism. Walking upright on two legs is one of the defining features of the human lineage, and it is, in metabolic terms, more efficient than the knuckle walking of our great ape cousins. But it required a fundamental reshaping of the pelvis, a rotation of the hip bones inward, a narrowing of the pelvic outlet, a structural compromise that allowed for efficient two-legged locomotion, but that simultaneously reduced the width of the birth canal. The pelvis that walks well is not the pelvis that gives birth easily. The second pressure was the expanding human brain. Our genus, Homo, is defined in large part by increasing brain size from roughly 600 cubic centimeters in early Homo habilis to approximately 1400 cubic centimeters in modern Homo sapiens. A brain that size, housed in the skull of a newborn infant, must pass through a birth canal that bipedalism has made narrower than any other comparable primates. The result is what anthropologists call the obstetric dilemma, a structural conflict between two adaptive pressures that has made human birth uniquely difficult, uniquely dangerous, and uniquely dependent on social support since long before the Ice Age began. Human infants are born dramatically earlier in their neurological development than the infants of any other great ape. A chimpanzee newborn enters the world with a brain at approximately 40% of its adult size. A human newborn's brain is at roughly 25% of its adult size at birth. Because if gestation extended long enough for further brain development, the skull would become too large to pass through the birth canal without killing both mother and infant. This is why human babies are so completely helpless at birth, so neurologically incomplete, so utterly dependent. They are, in a precise biological sense, born early, born into a state of developmental prematurity that requires years of intensive care before the infant can function with anything approaching independence. And that prematurity is the direct consequence of a birth canal that natural selection has never found a satisfying solution for. For a woman giving birth in an Ice Age shelter 40,000 years ago, these structural realities were the same realities they are today. The skull size, the pelvic dimensions, the rotational mechanics of human birth, all of it was present in full force, without any of the medical interventions that make modern birth significantly safer than it was. For most of human history, what she had instead was something older and more fundamental. Another woman, cooperative birth, the presence of an experienced attendant during labor and delivery, is functionally universal across every traditional human culture for which we have data. Every known human society, without exception, has practices around birth attendance. There is no traditional human group in which women routinely give birth entirely alone. This is not cultural convention in the way that marriage customs or food taboos are cultural conventions. It is a biological necessity that the structure of human reproduction created, and that human social organization has accommodated, for at least as long as Homo sapiens has existed. The need for a second person during human birth is older than agriculture, older than language as we understand it, older than the Ice Age itself. The practice of midwifery, of experienced women guiding other women through labor, knowing what normal looked like and what deviation required intervention, traces to approximately 40,000 years ago in the archaeological and anthropological record, not as a profession with formal training and institutional credentials, as a body of knowledge transmitted from woman to woman, across generations, accumulating with each birth and each loss, becoming more precise and more capable across thousands of years of practice. Now consider what happened to that knowledge system during the Ice Age's worst decades, when nutritional stress was severe enough to mark 1 in 3 children's teeth, with evidence of starvation. When a woman arriving at labor had spent the preceding months not in nutritional adequacy, but in the careful, exhausting work of maintaining barely enough caloric reserves to reach full term. When the infant's birth weight was influenced by the same food scarcity that had already shrunk average adult stature by 4 inches across 2 generations, nutritional deprivation during pregnancy affects fetal development in specific, measurable ways. Low maternal body weight at conception is associated with increased rates of preterm labor. Inadequate caloric intake during the 3rd trimester reduces infant birth weight and increases the mechanical challenges of delivery. A smaller infant is not necessarily easier to deliver, and in some configurations, a malnourished mother's reduced pelvic tissue resilience creates complications that a well-nourished mother's body handles more smoothly. The combination of a nutritionally stressed mother and the structural challenges of human birth is not simply additive in its difficulty, it is multiplicative, and yet the species continued. The births happened. The women survived them. Not all, but enough. Their infants survived, not all, but enough. And the knowledge that allowed those survivals to accumulate was passed between women in rock shelters and at the edges of fires, in the intimate, specific, practical language of women who had seen this before. The postpartum period added its own demands to everything that came before. Recovery from delivery burns calories. Nursing an infant, producing the breast milk that a Paleolithic infant needed across its first years of life requires approximately 500 additional calories per day above the mother's baseline metabolic needs. 500 calories per day for the duration of nursing, on top of everything else the Ice Age asked of a woman's body. And Paleolithic nursing continued for significantly longer than modern practices in high-income countries. Ethnographic studies of traditional hunter-gatherer populations suggest nursing durations of 3 to 4 years were common, providing the infant with immune protection, caloric support, and the mother with a degree of natural fertility suppression that provided some spacing between pregnancies. One estimate based on the caloric mathematics of Ice Age survival suggests that bringing a single child from birth to the point of weaning required enduring to full Arctic winters, to full seasons of -15 degrees, 2 seasons of shortened daylight and depleted food supply, while simultaneously maintaining the additional caloric demands of lactation. To winters of providing 500 extra calories per day from a food supply. That was itself under severe stress. This is what the figurines were encoding. This is what the female body carved in mammoth ivory near the glacier front communicated to the young woman holding it. Not a beauty standard, not a sexual fantasy, a survival threshold. The reserves required to do what you are about to do. The body condition that makes the mathematics possible. Stay with me as we move to the next part of this story. Because what happened after birth, the long, remarkable contribution of the women who were no longer giving birth, is the piece of the Ice Age's female story that is most surprising, most specific, and most personally meaningful to many of the women listening tonight. Every other great ape on Earth does something that humans do not. Something so fundamental that we barely notice its absence in our own species. The way you stop noticing the color of the walls. In a room you live in chimpanzees, in gorillas, in bonobos and orangutans, our closest living relatives. The females remain reproductively active for essentially their entire adult lives. Fertility declines gradually with age and ends only at death. There is no chimpanzee menopause, no gorilla menopause, no sharp, evolved cessation of reproductive capacity at midlife in any other great ape female, followed by decades of vigorous, healthy post-reproductive life. There is in us the human female menopause, the complete cessation of ovarian function typically occurring in the late 40s or early 50s, followed in most women by decades of healthy, capable post-reproductive life, is one of the most biologically unusual features of our entire species. It is found in humans, in some whale species, and in almost nothing else among complex animals. It is specifically female. Male reproductive capacity declines gradually with age, but does not end at a defined biological threshold the way female reproductive capacity does. And it is ancient. It predates the Ice Age. It predates agriculture. It predates every cultural invention we have made. It is written into the female genome at a depth that tells us it was not an accident, and that it was not without consequence. The question is, why? What possible evolutionary advantage could the female body derive from ending its reproductive capacity decades before the end of life? Everything we understand about natural selection tells us that organisms maximize their reproductive output across their lifespans, ending reproduction early, and then living for 30 or 40 more years in a non-reproducing state, appears at first glance to reduce a woman's total reproductive contribution to the next generation. It appears, by the logic of evolution, like a disadvantage, unless what that post-reproductive woman does with those 30 or 40 years is so consequential for the survival of her existing descendants that it more than compensates for the reproductive output she is foregoing, unless the survival advantage of having a living, capable, experienced, and non-competing for reproductive resources grandmother present is large enough, consistent enough, significant enough in terms of grandchild survival, that it actually increases the total genetic contribution a woman makes to future generations, more than additional pregnancies would, This is the grandmother hypothesis. It was developed primarily by the anthropologist Kristen Hawkes at the University of Utah, based on years of fieldwork with the Hadza people of Tanzania, one of the few remaining populations living in a traditional hunter-gatherer lifestyle. That provides a broadly comparable window into Paleolithic social organization. Hawkes initially went to study Hadza women's foraging, with an interest in understanding the general economics of food acquisition. What she found redirected her work. For decades, the Hadza grandmothers, the postmenopausal women in the community, were among the most productive and most consistent foragers in the entire group. Not in terms of hunting large game, but in terms of total food acquired per hour of effort. The grandmothers were exceptionally efficient. They dug tubers with the knowledge that comes from 30 years of learning exactly where in the landscape particular species grew at each season. They gathered, processed, and prepared food with a speed and skill that younger women were still developing. And because they were not pregnant, not nursing, not managing the caloric demands of supporting an infant body growing inside their own, they could give their labor continuously and reliably in ways that reproductive age mothers simply could not. And then Hawkes documented the effect of this on the generation below, the children of Hadza women whose mothers were still alive, and nearby had measurably higher survival rates than the children of women whose mothers had died. The grandmother effect, statistically significant, appearing consistently across multiple sites and multiple years of data, was real. A living maternal grandmother in the community was a measurable predictor of child survival, not a minor one. Subsequent research extended this finding across multiple traditional populations. Studies the Finnish historical records. Populations that lived in pre-industrial conditions broadly comparable in food security to hunter-gatherer groups showed the same pattern. Maternal grandmothers living in proximity to their daughters. Families were associated with significantly reduced child mortality across the first 5 years of life. In one analysis of Gambian village records, the presence of a maternal grandmother was associated with a reduction in child mortality of approximately 50% in the post-weaning period, the phase of early childhood when children transition from breast milk to solid food and face their highest nutritional vulnerability. The evolutionary implication is profound, and it plays out over generational time in a way that requires a moment of careful attention. If postmenopausal women consistently improve the survival of their grandchildren, if having a living grandmother present meaningfully increases the likelihood that those grandchildren will survive to reproduce themselves, then women who live longer after menopause will leave more surviving descendants than women who die at or around the time of their last childbirth over hundreds of generations. The genes associated with longer post-reproductive lifespan will spread through the female population, carried in the bodies of the more numerous descendants of long-lived grandmothers. And over time, the human female lifespan will extend specifically beyond reproduction, longer and longer, generation by generation, because living longer after menopause was worth it. This is the evolutionary mechanism by which women came to live as long as they do, not as a byproduct of general human longevity, not as a neutral consequence of having survived long enough. as a specifically selected for feature of female human biology, driven by the consistent, measurable, generation-spanning survival advantage that grandmothers provided to their daughters' children. During the Ice Age, this dynamic was operating under the most intense pressure it has ever faced in the modern human lineage. In the years of most severe caloric scarcity, the winters when the nursing mothers were maintaining the narrowest possible margins between survival and failure, the postmenopausal grandmothers were the buffer. They were the labor that kept the food supply adequate when young mothers could not forage at full capacity. They were the experience that recognized early complications in labor and knew what to do about them. They were the child care that allowed nursing mothers to rest and recover and maintain the fat reserves that their infants depended on. They were the memory, the long, specific, locationally precise knowledge of where food could be found in every season, in every kind of winter, in every kind of scarcity, that no younger woman had yet had time to accumulate. And here is what this means for the women listening tonight, who are in the postmenopausal years of their lives, or who are approaching them, or who love someone in them. The years that follow menopause, the decades of post-reproductive life that contemporary culture so often treats as diminishment, as a trailing off, as the body winding down toward irrelevance, are not an accident of modern medicine. They are not the result of recent improvements in nutrition and healthcare extending life into a stage that evolution never planned for. They are older than agriculture. They are older than any city, any written language, any system of organized religion. They were selected for, specifically and repeatedly, across hundreds of thousands of years of exactly the kind of high-stakes survival conditions that the Ice Age represents at its most extreme. The human female lives long after her reproductive years because her survival past those years was one of the most valuable things a human community could possess, because the grandmother, who remained strong and capable and present, consistently increased the survival of the generation below her, because the ice and every hard season before and after the ice proved this again and again and again. You carry this, not metaphorically, in the biology of your lifespan. In the length of the post-reproductive years your body was built to sustain. This is the answer that had been overlooked for decades, hiding in the survival statistics of grandchildren across cultures on 6 continents, waiting for someone to look at the right data and ask the right question. There is an asymmetry in human skin pigmentation that most people have never noticed, because it is subtle enough to be invisible without measurement. But it is there, in the data, in the genetic record, in the evolutionary logic of what the female body needed in order to reproduce successfully at high latitudes. And it runs directly through the Ice Age. The broad story of human skin color is reasonably well known. Our earliest hominin ancestors in equatorial Africa evolved deeply pigmented skin as protection against intense ultraviolet radiation. The UV levels at the equator are high enough to degrade folate in the blood. Folate being a B vitamin that is essential for fetal neural tube development. In the earliest weeks of pregnancy, the weeks before a woman typically knows she is pregnant, A woman with insufficient UV protection at the equator risks fetal neural tube defects from folate degradation. Selection for dark skin at equatorial latitudes was strong, consistent, and substantially driven by the reproductive consequences of UV folate destruction. When populations began moving north out of Africa, into the Middle East, into Central Asia, into Europe, the UV environment reversed. At higher latitudes, the concern is not too much ultraviolet radiation. It is too little. The same UVB wavelength that destroys folate at the equator is also the wavelength that drives vitamin D synthesis in human skin. Without adequate UVB, the body cannot produce vitamin D in the quantities needed for healthy bone mineralization, immune function, or reproductive success at high latitudes. Dark skin that had been protective at the equator became a liability, blocking the limited available UVB and preventing adequate vitamin D synthesis. Selection pressure reversed. Lighter skin, skin that allowed more UVB to penetrate and drive vitamin D production, became advantageous, and over tens of thousands of years of populations living in Europe and Northern Asia, skin pigmentation lightened. This is the baseline version of the story. What the baseline version leaves out is the female dimension. Pregnancy and lactation place the female body under vitamin D demands that have no equivalent in male physiology. The developing fetus draws calcium from the mother's bones across 9 months of gestation at rates that require adequate vitamin D to replenish. A pregnant woman deficient in vitamin D faces elevated risks of preeclampsia, gestational diabetes, preterm birth, and low infant birth weight, all conditions with direct consequences for whether the infant survives its first year. The nursing infant's bone development, immune function, and neurological growth are all dependent on the vitamin D concentrations in breast milk, which are directly tied to the mother's own vitamin D status. At high latitudes, at the latitudes that Europeans and Northern Asians were occupying during and before the Ice Age, a pregnant or nursing woman with insufficient skin depigmentation faced reproductive failure at rates significantly higher than her male counterpart facing the same UV environment. A man who was too darkly pigmented to synthesize adequate vitamin D suffered personal health consequences. A woman in the same situation suffered those consequences plus the potential loss of her pregnancy, or her infant, or both. The selective pressure for lighter skin at high latitudes was therefore stronger in women than in men, specifically because of the vitamin D demands of female reproductive biology. And this is not just theoretical inference. Several independent genetic analyses of European and East Asian populations have found selection signatures for skin depigmentation that are measurably stronger in the female lineage than in the male lineage of the same population. The selective sweep that lightened skin in northern populations moved faster and farther in women than in men, because the stakes for women were higher. Think about what this means in the context of the Ice Age, as populations contracted southward, huddled in refugia, and then slowly expanded northward again as the climate began to warm. The women at the northern edge of any population's range were under the most intense reproductive pressure from vitamin D deficiency. The women whose skin had lightened enough to synthesize adequate vitamin D during the brief Low-angle sunlight of northern winters were the women, whose pregnancies were most likely to reach full term, whose infants were most likely to survive. The first winter, whose nursing lasted long enough to cover the critical developmental windows of early childhood. And so, generation by generation, across the northern populations, the female skin pigmentation distribution shifted, driven by the vitamin D demands of reproduction in low UV environments. There is a second layer to this that involves the EDA gene we explored in Chapter 5, the gene whose V370A variant was selected in the Beringian population during 9,000 years of near-total UVB darkness. Recall that this gene variant increases the ductal branching complexity in mammary tissue, improving the transfer of fat-soluble vitamins, including vitamin D, from a mother's body into breast milk. The EDA story and the skin depigmentation story are not separate narratives. They are two parallel responses to the same problem. How does a female body sustain a healthy pregnancy and nurse a surviving infant in an environment where the sun provides almost no vitamin D? Skin lightening was the long-term answer. The anatomical adaptation that slowly improved the body's capacity to manufacture vitamin D from the available sunlight. The EDA gene variant was the complementary answer, improving the efficiency of transferring whatever vitamin D could be synthesized into breast milk, so that even women whose personal vitamin D levels were inadequate could provide their infants with better nutrition than their own bodies were receiving. These two adaptations, working together, represent something worth appreciating in its full dimension. They represent the female body's response to an impossible constraint. Live in darkness at high latitude, maintain a pregnancy, nurse an infant, and somehow deliver enough vitamin D across the entire system to keep the next generation alive. No single adaptation solved this problem completely. The body needed multiple strategies operating simultaneously, and it found them over tens of thousands of years of selection, and wrote them into the female genome, where they still operate today. Here is what this means in your body right now, tonight, wherever you are listening. If you are of European descent, the skin you are in is lighter than your ancestors' skin from equatorial Africa, and the selective pressure that drove that lightening was stronger in your female line than in your male line, because the stakes of vitamin D deficiency for women were higher. If you are of East Asian or Indigenous American descent, you may carry the EDA V370A variant, the Ice Age gene, selected during 9,000 years of Arctic darkness, still increasing the ductal complexity in the mammary tissue of female bodies in your lineage. These are not abstract ancestry facts. They are the specific record of what the female body did to keep the chain going in you. The light on your skin and the structure of your breast tissue both carry the answer to a question that women's bodies were asked 40,000 years ago and answered under conditions that most of us will never face, with a precision and a persistence that should be allowed to be genuinely astonishing. In a cave in the Dordogne region of France, on a stretch of limestone wall that has been sheltered from weathering by the geometry of the rock shelter above it, there is a carved frieze. Horses, mostly several bison. What may be a deer? The Carving is technically accomplished in a way that is not incidental. The lines are confident, the proportions considered, the scale of the animals in relation to the wall surface the product of spatial planning rather than improvised marks. Someone stood in front of this wall repeatedly over hours or days or longer and worked the stone with purpose and skill. The frieze at Cap Blanc is approximately 15,000 years old. For most of the period since its discovery, researchers assumed the sculptor was male. The assumption was not based on evidence. It was based on the default interpretive framework of a scientific culture that had not yet seriously examined its own presuppositions about who made things and who did important things and whose accomplishments were worth recording. Then a skeleton was found beneath the center of the frieze, excavated in 1911. Sold to the Field Museum in Chicago, long catalogued as male, as most Paleolithic skeletons were catalogued without rigorous osteological verification. Later reanalysis identified the individual as female, approximately 25 to 35 years old at death. She was buried in the most honored position possible, at this site, directly beneath the most prominent section of the carving. And when a cast of her skeleton was repositioned in the original burial location by the anthropologist who had analyzed her remains, something became immediately apparent. The muscle attachment markers on her left arm were more pronounced than those on her right. She was left-handed, and the directionality of the tool marks in the carving is consistent with a left-handed sculptor. The sculptor of Cap Blanc was almost certainly a woman. She was buried in a place of honor, in front of her own artwork, 15,000 years ago, in a period when the human population of Europe was beginning to recover from the worst of the glacial maximum's devastation. She is not unique in the record. She is simply one of the clearest examples of what the record is beginning to show with increasing consistency, that the assumption of male artistic and intellectual dominance in the Ice Age was never an evidence-based conclusion. It was an artifact of who was doing the interpreting and what they expected to find. The hand stencils. Dozens of caves across Europe contain hand stencils, outlines of human hands pressed against the cave wall, with pigment blown or painted around them, leaving the hand's silhouette preserved in ochre or manganese dioxide for tens of thousands of years. For generations, researchers assumed these were men's hands. They were assumed to be hunters mocking their presence, or shamans performing rituals, or warriors claiming territory. Then archaeologists began actually measuring the hands, analyzing the digit ratios, the overall proportions, the size distributions across multiple sites. The results were not what the assumption predicted. At multiple cave sites across France and Spain, the hand stencils show distributions that are strongly consistent with adult female hands, and in some locations the proportion of hands with female consistent proportions runs as high as 75%. 3/4 of the hands pressed against those cave walls in the firelight 40,000 years ago were women's hands. But there is a story in the Ice Age record that matters even more than the cave art for understanding what women's knowledge and women's labor actually contributed to survival. And it lives in the most fragile and least preserved category of human material culture. Textiles. The image of Ice Age people in animal skins is so deeply embedded in the popular imagination that it functions almost as biological memory, as if we somehow know it to be true without ever having been taught it specifically. The fur-clad cave person is the visual shorthand for prehistoric humanity. But the archaeological record, when examined with care, tells a different story about what people were actually wearing and making and using. In the year 2000, archaeologist Olga Sofer published a study that changed the material culture record of the Upper Paleolithic in a way that has not yet been fully absorbed into popular accounts of the Ice Age, examining fired clay fragments from Pavlovian sites in the Czech Republic. Sites dated to approximately 27,000 years ago, at the height of the last glacial maximums approach. Sofer identified more than 80 impressions of woven textiles, not animal skins, not furs, woven fabric, cordage, structured textiles produced using multiple weaving techniques including plain weave, twilling, and net-making construction. The textiles themselves had not survived. Organic fiber materials essentially never survive across 30 millennia of burial. But the impressions they made in wet clay before that clay was fired told the complete story of their structure. These were sophisticated manufacturing products. The net-making construction in particular, the diagonal crossing pattern of cordage knotted at regular intervals to create open mesh, required significant technical knowledge to produce. It was not a technique discoverable by accident. It was a technique taught, passed from one person who knew it to another who was learning it, accumulated over generations of practice and refinement. And in every traditional human culture for which we have ethnographic data, textile production was predominantly or entirely women's work. This is not a universal law of human behavior. There are traditional societies where men weave, but across the broadest cross-cultural survey, the making of nets, cordage, baskets, and woven cloth is associated with women's knowledge and women's labor with a consistency that allows reasonable inference backward into the Paleolithic record. Now, consider what those nets actually meant to an Ice Age community, facing the food scarcity of the glacial maximum's worst decades. A single large game animal, a reindeer, a horse, a young mammoth, could feed a band of 30 people for several days, but large game was becoming harder to find. As the climate shifted and the megafauna populations declined, or migrated to ranges increasingly distant from human settlements, the reliable food source that large game hunting represented was contracting. The archaeological record from last glacial maximum sites shows a consistent shift towards small game, rabbits, hares, birds, small rodents in the faunal assemblages, more small animal bones, more evidence of high-volumed small game processing. A fundamental shift in the food acquisition strategy of populations under caloric pressure. High-volume small game acquisition is only possible with net technology. A single hunter can run down and kill individual rabbits. But individual rabbits are a trivial caloric return for the effort invested. A coordinated group using drive nets. Length of net arranged across a landscape feature, with beaters driving animals toward the net, can take dozens of animals simultaneously. The caloric return per unit of labor invested is transformed entirely. This is not merely a useful alternative strategy. During the Ice Age's worst decades, it may have been a survival strategy. The nets that enabled it were made by women. The knowledge of seasonal warren locations that directed the drives was held by women, who spent most of their time in proximity to the local landscape. The coordination of the drives themselves, which appear in the archaeological record as the work of women, older adults, and children rather than the prime-age male hunters, was organized around women's knowledge and women's labor. The nets saved people. The women who made and maintained and used them were not support staff for the hunters. They were running a parallel and complementary food acquisition system that, in the worst years, may have been more reliable than hunting megafauna that had ceased to be reliably available. The Red Lady of El Miron, a woman buried in a cave in Cantabria, Spain, approximately 18,700 years ago, 35 to 40 years old at death. The only adult Ice Age burial found anywhere in the entire Iberian Peninsula, the only one in a region that held human populations for thousands of years, covered in an elaborate, hematite crystal-rich ochre that sparkles visibly even in photographs taken today, that when it was fresh would have caught firelight and glittered in the darkness of the shelter, buried with care that communicates, across 18,000 years of silence, that this woman was recognized as significant by the people who laid her down. We do not know her name. We do not know what she knew or what she made. But someone believed she was worth honoring in a way no one else in that landscape was. She was worth the ochre, worth the attention, worth the memory. These are the women whose knowledge was never written because writing did not yet exist, whose contributions were never formally recorded because later systems were not built to remember. The Ice Age, their absence from the story, was not deliberated, was the slow weight of small assumptions, repeated until prehistory became a world where men acted and women watched. That picture is wrong. The bones, the teeth, the hand stencils, the clay impressions and the buried woman beneath the carved frieze say it. The truth is simpler. Women fed the band, carried the land in memory, left their marks on stone, gave birth in the cold, extended human life, and changed cell by cell long before science understood it. Around 19,000 years ago, the ice began to leave, not abruptly, not in any way that the people living through the early phases of the warming would have recognized as a reversal. The change was in the direction of the trend, the gradual, century by century tilt of the climate back toward warmth that would, over the next 8,000 years, completely reshape the planet. But it began quietly, as such vast changes always begin, in increments invisible to any single generation. A winter slightly less severe than the last, a spring that came slightly earlier, a plant returning to a hillside where it had not grown for a generation. The last glacial maximum had peaked approximately 22,000 years ago. With the continental ice sheets at their greatest extent, the temperatures at their lowest, the human populations at their most contracted and their most genetically isolated. By 19,000 years ago, the retreat had begun. By 15,000 years ago, The warming was measurable across multiple paleoclimate proxies. By 12,900 years ago, however, the process lurched. The Younger Dryas event, one of the most dramatic rapid climate oscillations in the geological record, plunged the northern hemisphere back toward glacial conditions over a period as short as a decade. The brief flash of warmth that had allowed some populations to begin expanding northward was suddenly revoked. The trees that had started to return retreated again. The populations that had followed the warming northward found themselves, once again, in cold they had just escaped. Then, around 11,700 years ago, the Younger Dryas ended as abruptly as it had begun. Temperatures rose steeply. Ice retreated. Coastlines shifted as the ocean reclaimed the land that reduced sea levels had exposed. The Bering Land Bridge, above which the ancestral population of the Americas had been trapped for 9,000 years, was submerged. The continent they had been isolated from for so long became permanently connected to the global ocean that now separated it from everything else. And the world that emerged from the end of the last glacial period was, climatically, very close to the world that still exists. What the thaw brought, over the millennia that followed, was a loosening of the grinding caloric pressure that had defined female biological experience for 40,000 years. The warming brought forests northward, brought plant food diversity back to landscapes that had been near tundra, brought the megafauna's ranges into more predictable patterns, eventually enabled the development of agriculture in multiple regions. Simultaneously, the mathematics of daily caloric acquisition changed, not overnight, not in any single generation. But the direction of change was toward adequacy, and then toward surplus, in ways that the Ice Age had never permitted. As the food supply became more reliable, something shifted in the archaeological record of female body representation. The Venus figurines, those carved records of the survival threshold, those carefully measured embodiments of the body reserves that Ice Age pregnancy required, became less common. The full-bodied female form that had been carved obsessively across 24,000 years of cold begins to appear less frequently in post-glacial sites. The leanest figurines in the entire corpus, based on the 2020 study's measurements, are the ones dated to the warmest post-glacial periods, when nutritional stress had eased enough that the body condition they depicted was no longer the emergency it had been. The survival instruction was no longer urgent. The ideal it encoded, the specific body condition that the worst years of the Ice Age required, was becoming less rare, less precarious, less the margin between living and not. And so the intensity of its transmission in carved form diminished. But the biology did not diminish. Here is what the thaw could not undo. The subcutaneous fat distribution that kept women alive in the cold is still present in the female body. It has not been dismantled by 10,000 years of relative nutritional adequacy. Evolution does not reverse its architectural decisions on the timescale of mere millennia, especially not decisions that were reinforced by 40,000 years of sustained selection. Pressure, the fat carried in women's hips and thighs today, is the same fat, in the same locations. governed by the same hormonal mechanisms that it was when the glacier sat 50 miles north. The hormonal intelligence that pauses reproduction during caloric insufficiency is still operating. It still responds to the same signals. A woman under severe nutritional stress today still experiences the same hormonal recalibration, the same hypothalamic response, the same reduction in ovarian activity that women in Ice Age rock shelters experienced when winter stripped the food supply to its margins. The body has not been updated to reflect the existence of grocery stores. It is still running the software the Ice Age wrote. Because that software has not been replaced by anything and the hardware it runs on has not changed. The ETA V3708 gene variant, the Ice Age gene, selected during 9,000 years of Arctic darkness in the Beringen refugium, still increasing ductal branching density in the mammary tissue of hundreds of millions of women in East Asia and the Americas, is still functional. The genetic isolation that allowed it to reach near fixation ended when the ice retreated, and populations dispersed through the Americas and reconnected with the broader Asian population. But the gene did not disappear. It is not being selected against in current populations. It is not neutral. Exactly. It still affects the structure and function of breast tissue in the women who carry it. It is simply present as a passenger now rather than a driven adaptation, carried in the bodies of the descendants of the women who survived 9,000 years of Arctic darkness. The grandmother hypothesis is still playing out. Postmenopausal women are still, in populations worldwide, consistently associated with improved grandchild survival and well-being. Modern studies across multiple traditional and transitional societies continue to document the grandmother effect, the evolutionary selection that created the human female post-reproductive lifespan has not stopped operating. Because the ice retreated, it continues quietly in every population where the presence of living maternal grandmothers is associated with better outcomes for children, which is essentially every population. That has been carefully studied. And the knowledge, the accumulated, embodied, transmitted, woman-to-woman knowledge that was the true survival technology of the Ice Age, is still moving through human culture by the same mechanisms it always has. Not in books, not in institutions, not in formal systems with credentials and hierarchies. In conversations between women. In the specific kind of attention that women who have lived long pay to the women who are still learning what it means to live in a female body. In the capacity to recognize something important in what another woman is experiencing. Because you have been there yourself, or because someone who was there told you. This is where every thread of evidence finally converges. Not in a single dramatic discovery, not in a gene or a figurine or a skeleton. In the recognition that what kept the species alive through 40,000 years of cold was not any single biological adaptation, however remarkable, and not any single behavioral strategy, however sophisticated. It was the combination, the fat reserves and the midwifery, the breast milk chemistry and the grandmother foraging, the textile technology and the cave art, the hormonal intelligence and the long post-reproductive life, all of it woven together. Like the nets that caught the food that fed the band, into something that no individual woman could have been, but that all of them together, across generations, were. We began this story with a question that most history has not asked. Not how did humans survive the Ice Age? The general answer to that is known and often told. But what did surviving the Ice Age cost a woman's body? What did it ask of her? Specifically, what did it change in her? And what of that change is she still carrying? After 40,000 years and 104 minutes, we have the answer. Or rather, we have several answers, all true simultaneously, all pointing in the same direction. Surviving the Ice Age asked women's bodies to become more specifically, more functionally, more sophisticatedly female than they had been before. Not in a cultural sense, not in the sense of roles assigned or behaviors expected. In the biological sense, the selective pressure of 40,000 years of cold pressed against every specifically female feature of the human body, the fat distribution, the reproductive hormonal system, the breast tissue, the lifespan, the relationship between generations, and it refined each of them in directions that directly served the continuation of human life. The fat carried in women's bodies is insulation, and nursing reserve and pregnancy fuel, and the survival calculation of a species, running very close to the edge of what was possible. It is not incidental to female biology. It is central to female biology in ways that the Ice Age made permanent. The hormonal intelligence that adjusts female reproductive capacity to the available food supply is one of the most precisely calibrated survival systems in mammalian biology. It is not a flaw or a vulnerability. It is the body's most honest response to the conditions it is in, a response that allowed women to survive the winters that would have killed a woman committed to reproduction, regardless of her reserves, and to reproduce successfully in the springs that followed. The EDV3708 gene in the bodies of hundreds of millions of women in East Asia and the Americas is 9,000 years of Arctic darkness written into breast tissue structure. It is the record of mothers nursing their babies through conditions that should have been impossible. It is the genetic signature of a problem solved by a female body that had no other options and found. D1 anyway, cell by cell, generation by generation, in the dark above the world, the postmenopausal years, the decades of vigorous, capable, knowledgeable life that extend beyond reproduction in the human female and in no other great ape, are the product of grandmothers who survived and stayed and fed and guided and supported and knew. They are not a medical achievement. They are an evolutionary one. They were worth having when the ice was 20 feet thick, 50 miles north of where your ancestor was trying to nurse a baby through the winter, and they are worth having now. And the women who are living them are not past their usefulness. They are in the fullest expression of one of the most specifically human features of the female lifespan. Now let this settle for a moment, because there is one more thing worth saying, and it is the thing that brings this entire journey from an ivory figurine in a German cave to the woman lying here tonight to its proper close. You are the continuation of a line that has never broken, not once. Not through the population collapse that took more than half the human population of Europe. From 300,000 to 130,000. Not through the 9,000 years of Arctic darkness in the Barringen refugium. Not through the caloric mathematics of pregnancies sustained on the edge of insufficiency, and winters endured in shelters that kept the cold outside by the narrowest margins. Not through the labors attended by the cold hands of experienced women. In rock shelters and open camps across a world that was trying very hard to end the human experiment. Your direct female ancestors survived every one of those things. Every single generation, going back past the Ice Age, past the beginning of modern human behavior, past the emergence of Homo sapiens itself. Every woman in your direct maternal line survived long enough to leave a daughter who survived. Long enough to leave a daughter who survived long enough, eventually, to arrive at you. There is not a single gap in that chain. There cannot be, or you would not be here. The body you live in, the one that stores fat in patterns that modern culture pathologizes, the one whose hormones are sometimes confounding and often inconvenient, and occasionally astonishing. The one that ages in its specifically female way, with its specifically female timeline, is the accumulated result of every woman in that unbroken line, doing what was required to keep the chain intact. Their bodies are in your body. Their adaptations are your adaptations. The intelligence the Ice Age wrote into the female form is the intelligence operating in you. Quietly, continuously, in ways you will never consciously notice because you do not have to. It is already there. It was already there before you had any word for it. This is what was happening to women's bodies during the 40,000-year Ice Age, that nobody talks about. Not a passive endurance, not a suffering merely survived, a refinement, a deepening, a 40,000-year conversation between the female body and the most extreme conditions it has ever faced in the modern human era. A conversation that ended, if it has ended, with the body knowing more about how to keep life going than it knew when the conversation began. The ice is gone. The conditions that demanded so much of those women have changed beyond recognition. But what they made is here, in you, tonight. Let that be the last thought as sleep comes. You are not at the beginning of something fragile. You are at the continuation of something extraordinarily durable. Something that has already survived everything it was asked to survive, and that has been carrying you and every woman who came before you through every winter, every darkness, every impossible season, for as long as women have existed. Rest now. The chain holds.